Let me explain you the setup before we start the inspection. We entered the part thickness of 1 inch. We entered the refracted angle of the probe, 60 degrees. And based on that, the machine is set up now. You can see these different color bands. This is the first leg and this is the second leg. What does the leg mean? Right here in this diagram, this is the first leg, this is the second leg. So this point on the plate corresponds to this point on the screen. This point on the plate, which is the bottom of the plate, corresponds to that point on the screen. And then the very top, if the sound goes up to here, would be the full V path, and that would correspond to this point on the screen. So if there is an indication at the bottom of the plate, it would show up right at this point. Now let us start scanning the plate and see where the indications appear. So I put the probe here and we see a signal. That signal is shown here. As per our calculations, for this signal the RA is 1.295 and the DA is 0.993, which means that it's at the bottom of the plate. But based on RA, we need to find the location. So I take a ruler and measure 1.295 from the front of the probe. And if you can see here on the ruler, if you can zoom in, and 1.295 actually falls at this point. So from this point, it's 0.993 below this point. Now let me go to the drawing of this plate and we will transfer this point from this plate to the drawing. So that point from the plate corresponds to this point on the drawing, and then from there we have to go 0.993 inches down, which is basically 1 inch, and that would correspond to the point here on the weld. So that reflection is from the bottom cap of the weld. Now let's proceed scanning and look for the second indication. Again, this is a signal from the cap, and I will keep scanning here to look for other indication. Let's see, and let me go to this indication right here, and that indication, as you can see, peaks up right there. And again, just looking at the legs, we can say that the indication is at the bottom of the plate, and which is DA is 0.989. The signal is here. I've set up the gate to cut the signal. It's at the bottom of the plate. Now we have to find the location relative to the weld cap, and that we will find using the RA. The RA is 1.269 from the probe location, and if I take it, can you zoom on that? Okay, so we go here and then I go 1.269, which is 1.1, 1.2, 1.269, so it comes out here. I'll mark this location here, which is right there. Then I will transfer this location to the drawing. Just remember this location here, and that corresponding location on the drawing actually is here, coming back from again here to here, and then from there we go 0.993 or 990 down, and that actually comes out to be right there. So that in fact would be, if there is a flaw here, what could that be? That would be a toe crack. So this is the signal coming from the toe crack. So again, it's very simple. You pick up the signal and then get the RA location, the depth location, mark it on the weld profile and see what it could be. So here is indication number 1. Okay, I will be scanning for the next indication. Here is the weld cap again. I'll keep scanning. And I run into this new indication, then I will peak it up. It peaks up somewhere here, and you can see it's multiple signals, and it peaks up right there. So once the signal peaks up, then we have to move the gate to catch the signal. And I move the gate on the signal. Make sure that the gate only cuts the signal of interest. Otherwise, it will give you a wrong measurement. So we are trying, our signal of interest is this one. The depth is 526 and the RA is 461. I'll go back, zoom in on the probe. I'll go 461, 0.461 from the front of the probe, which places me right there at the center of the weld. At the center of the weld. And from there, I have to go down 0.526, which is basically the middle of the weld. And that would put me at a location which is right there. Right there. So this is the indication number 2. Most likely this indication is a centerline crack because it's in the center of the weld. So this is indication number 2, and which is right there. Again, we measure the RA 0.461, measure it on the plate, find the location, transfer it to the drawing, which comes out to be here, and then check the depth on the machine, then go down 526, and that puts us here. Let's look for the third indication. I will be scanning right here. That's your weld cap. Oh, there is a signal right there. Then again, I'll move the probe to pick up the signal. And the signal actually peaks up before the bottom of the plate. So in fact, the signal peaks up somewhere at this location. And let's say it peaks up here. The next step would be to move the gate, which is the green gate, on top of the signal. So gate start right there. The depth of the flaw is 755. RA is 1.5 inches. So I will go 1.5 inches from the front of the probe, and that would basically put me, oh no, sorry, RA is 0.858. So it's 0.858 from the front of the probe wedge, which will place me right there. So this is the point where the flaw is, and this point then I will transfer it to the drawing, the corresponding location on the drawing, and that comes out to be right this point here. And then from here I have to go 755 down, which places me right there, and this is actually a location right here. So what could it be? If it's right here, it has to be lack of fusion. As you can see, we found 3 indications. One was the toe crack, centerline crack, and lack of fusion. The inspection was simple. The reason being, we have the right probe, we had the right setup, the range was set up properly, we found the exit point of the probe, we found the actual refracted angle of the probe, we entered all these parameters into the system, got the right setup, and then we got the right values of RA and DA. If you enter the wrong values of the probe, refracted angle, the X value, then everything will go wrong, because, for example, this indication 3, in case we had the wrong value of RA and we placed it right here, it probably is not lack of fusion, it's most likely going to be slag. So just a little bit difference from here to there in RA, which could be just 0.1 or 0.2 inches, will make a difference in the interpretation of the flaw. As you know, a slag can be acceptable, but lack of fusion is actually a rejectable flaw. That basically concludes the demonstration of the weld inspection. If I have to go to a different weld, means the different thickness, for example, we have to go to a 1/2 inch thick weld. The only thing I would change would be the thickness in the machine. So I'll go to here, go to trig, and instead of 1 inch thick, I will change it to 1/2 inch thick. If the thickness is 3/4 inch, then we will change it to 3/4 inch. if the refracted angle of the probe is 45 degrees we are using, then we will change it to 45 degrees. So as we change these parameters, these legs will change. If we change the probe, then we will have to change the X value. And that's how the system is set up, and that's how the inspection is done. Now, the way I have explained it is very straightforward. You really don't have to use any trigonometric formulas because they're already built into the machine. And all you have to do is set up the machine properly, get the proper RADA, and then have a drawing, which is an actual drawing of the well being inspected, and then place the indications on it, and then interpret the flaws. Thank you very much.